Hey guys, so I came home and found something kind of startling. You know how I was saying that this is baby stuff? Check this out. This is my son's dry erase board, and he's all up in here looking at series and parallel circuits. So, let's take a look at what he was doing, and maybe that'll help make some sense for all of us. Alright, so we got a series circuit here, and we got a parallel circuit here. And the difference is, in a series circuit, all the resistors, or the things that cause there to be a load, are right in a row. In a parallel circuit, the things are in these parallel tracks. So if you imagine some current going through, the flow of electrons going through the parallel circuit, when they get to this point, they have a choice. They can go forward, or they can go down. And then when you get to this point, they have another choice. They can go forward, or they can go down. In the series circuit, as this current starts flowing around, it has no choice but to go through everything in one big loop. So for this reason, we know in a series circuit that the current, or I, is the same for all those resistors. So if there's 1 amp of current here, there's 1 amp of current there, there's 1 amp of current there, there's 1 amp of current there, etc., etc. In a parallel circuit, if there's 1 amp of current right here, there's also got to be 1 amp of current right here, because everybody going through this circuit, is going to get back on the ride again and do it again. So everybody that leaves the station comes back into the station. But you don't necessarily have 1 amp of current going through this resistor or this resistor or this resistor, because they all kind of split up for a little while before they come back together down here. So this is where they all kind of join up again. So let's figure out if we can make the parallel circuit any simpler. We talked about current, so over here I is not the same, but what is the same is the voltage drop. So let's say these batteries are, I'm going to erase this one and make it green. Liam's got bad choice of colors. Say it's a 12 volt battery, and this is a 12 volt battery. We said think about voltage as going up high. It's like elevation. So we go up 12 volts. Well, if I'm 12 volts in the air on this side, and then on this side I'm on the ground, and I only drop when I go across a load, that's where that energy is coming back out of the circuit and doing something. So across this load, I must go down 12 volts. So across R1, there's got to be a voltage of 12 volts, really negative 12 volts. Across R2, negative 12 volts, and across R3, negative 12 volts. So, for a parallel circuit, we say voltage is the same. Now, that's not true in a series circuit. I go up a 12-meter hill, and then I go down a little bump. That doesn't have to be 12 meters. In fact, it can't really be if there's other resistors, because the voltage drop here, here, and here have to add up to 12. Now, if these were all the same resistance, so say 6 ohms, so let's call each of these resistors, in both circuits, a 6 ohm resistor. 6 ohms and 6 ohms and 6 ohms. And over here we have 6, 6, and 6. What I could do is say, well, let's put a little box around these and pretend that instead of 3 little resistors, I have 1 big resistor. Let's call it R total. In a series circuit, I would just add these up. So we'd say R total is R1 plus R2 plus R3 dot dot dot. In a parallel circuit, it doesn't quite work that way. Instead, we'd still put that big box over all these and pretend like there's just 1 big resistance or resistor R. But here, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So these are the rules that we follow for these 2 different types of circuits. But then the problem comes with what happens when you don't have a straight series or straight parallel. What happens if you have a circuit like this? Boom, boom. See, Liam didn't do this. This one's not quite child's play. Let's give ourselves an ammeter, And then we'll kind of do let's do a series. So we have one resistor, and then we're going to split into parallel resistors. Then we're going to come back together and go back to the battery. So in this one, we have a little bit of an issue, because we have the current's going around, it has to go this way, it has to go through that resistor, but then it can split and go one of these two ways. So it's parallel. But even though these are in parallel, you have to go over that bump, and you have to go through one of these tracks. So these aren't all parallel together. Even so, we can still say, or still treat it like there's one big box, and that one big box has a resistance R. The problem is, there's no easy way to jump from that circuit to the simplified version that we're going to make, which would just be this circuit. So there's our battery, ammeter, and one resistor. We can always pretend to circuits like that, or most. We can always pretend it look like that. But we can't just jump there. We got to do something in between. So we look at this again and say, well, can I find a section that's only series or only parallel? Well, let's see. Those two are not only series because there's a split. These two are not only series because there's a split. These two are only parallel. So maybe before we do this big box, we'll do a smaller one first. Alright, so let's draw this again. Boop, 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 boop. It works better if you make sound effects. Boop. Now, I'm drawing it again. There's my vertical, and it splits. But I'm going to pretend it doesn't split. I'm just going to pretend there's a resistor here. Let's call it RP. And RP is really just R2 and R3 in parallel. So that means 1 over RP is equal to 1 over R2 plus 1 over R3. If these are 6 ohm resistors, that would be 1 over RP equals 1 over 6 plus 1 over 6, which is 2 over 6. If 1 over RP is 2 over 6, then that means RP is equal to 3 ohms. So now I have a circuit where I have R1 and RP. These are only in series now. Since they're only in series, I can just add them up. So if R1 is a 6 ohm, 6 plus 3 is 9. So our total down here equals 9 ohms. If this is a 12 volt battery and a 9 ohm resistor, I can use Ohm's law, V equals IR, and say, alright, 12 equals I times 9. So I'm going to end up getting, 1 1/3? Yeah, 1 1/3. So I equals 1.3 repeating amps. Now, here's an important part. That's the current going through this circuit. And I'm pretending that this circuit only has one resistor and the current's the same everywhere. If I go back up to this one, R1 and RP are in series. So, if there's 1.3 amps going through that box and they're in series, this gets a current of 1.3 amps and this gets a current of 1.3 amps. However, if I jump back up, I can't assume that there's 1.3 amps in both of these resistors. Instead, what I do is I say, well, I got 1.3 amps there, and I know the resistance, so I'm going to apply Ohm's law again. V equals IR. In this case, it's RP. And we said RP was 3, and the current was 1.3. So we're going to get a voltage drop of 3.9. So if I have a 3.9 voltage drop here, and I have a 12 volt battery, that means right there I must have an 8.1 voltage drop. You gotta check my math, but I think that's right. So now we go back up a level. R1, we're already done, because that doesn't change. All the stuff that's true here is also true right there. But RP is really these things. And we know the current for RP, we know the voltage for R3 or RP. But really they're parallel, and the current's not the same, but the voltage is. So we now know for R3 we have a 3.9 volt drop, and for R2 we have a 3.9 volt drop. And if we know these resistors are each 6 ohms and 6 ohms, we can then figure out the current. So we could say Ohm's law again, and we're running out of room, so let's do it right over here. V equals IR, and we got a voltage drop of 3.9 equals current times 6 ohms. So our current is going to be 3.9 over 6 equals I, which is 0.515 amps, something like that. Again, check my math, but I think that's right. So that's the current right here. R1 is a current of 1.3 amps. So at this point, current of 1.3 amps, but at this point, we have a current of 0.515 amps. Now, it looks really messy, but that's because I had to work on this little dry erase board. But it's simple ideas. In a series circuit, current is the same. In a parallel circuit, voltage is the same. In a series circuit, add up your resistors. In a parallel circuit, 1 over R total equals 1 over all the R's. You can always take a complicated circuit and break it down to small, simple parts. When you see my son, make sure you say thank you for explaining all this. Bye now.